Um, yeah, so when I wrote that assignment, I knew what would happen. I knew it was your first time. I wanted that shit to be special. Um, it's good for it because this will not be the last time. I promise you, it will not be the last time that you accidentally push a big file to get that message. Arcade snoring. Like you can spend an hour with ChatGPT trying to fix that infinite history, and it's still confusing and horrible, right? Um, so the way to fix it is the cartoon. Is for real. Like this is faster and easier. Save all your new work in some new backup directory. Delete your whole repository. Download a fresh copy, and then move in just the files you want. Add commit push. All happy. It's 20 seconds, whereas trying to fix it the right way takes 3 hours. And that doesn't get faster. It still takes me about 20 minutes to like fix a broken kit. So good. Hopefully you got it all worked out. I'm gonna go ahead and go into your student repos here and collect your assignments. Awesome, unhappy looking colors. Let's do this. Thank you. There we go. Now forward rebates with unsaved changes. Change. So you should just leave it and revalidate it. I should just delete them. Yeah, that's what I'll do. Remove everything forcefully that has anything and then an underscore and then anything else. Okay, you're all gone. And now I'm gonna download the repositories crash. Somebody found a way to put a big file in there. Oh, that's separate. Because you left the G bit. It just fits under the. Okay,
Excellent.
all fixed. That's beautiful. Okay, ready for quiz? Go ahead and log into Laura. I won't make that part of your time limit. There you go. So in your quizzes, quiz 2 folder, you don't have one, make one. Create a new file, put that content in it. Connect it successfully. Then somehow transfer it back, documenting everything the whole time. And I will look at your README. You are about to use files, when you SCP or. Probably, document.
Was it really you APC or something?
Um, yeah, APC, 100% that's very working. If you use FileZilla, you can just say use FileZilla. Second warning. We need like notes in the during just with any commands you use, you use FileZilla, you can say transfer to FileZilla. Time's up. All right, hands off. So we got, yeah, bring up your readme for me. Just, that's it, or-
Well, yeah, I mean,
okay, that's good. Yeah, I
yeah, I had to make a this one.
yeah. Uh, fair enough. Don't use Google Docs to do code because it does stuff like auto capitalize. Yeah.
I usually just go through and like,
Best practice, just use a really boring text editor, plain text, yeah. Okay. Yep. So I'm gonna do the quiz here. Oops. Control C. Need to do. Computing. Don't have quizzes. Okay. So make their key. Quizzes. Quiz two. Right now, forward with file transfer test or something.
remote test.
Remote test. What? PXC. Okay, done. Now I'm gonna use FileZilla. Go about getting with his, there's two. There we go. The end. Not too bad. Anyone mad about this quiz? Y'all got it. Great. What did we leave off last time? We were like looking at scripts a little bit, and I asked you to try to make the first last script. Put the standard input and return the first and the last line of that standard input. Anyone get it?
Oh. I think I'm gonna get like the arrow.
Yeah, it's trickier than it seems. So I'm gonna go to like lessons. Or that's where we're playing with stuff. Okay. And I want to make a script that takes standard input, returns the first and last line. Well, okay. We've got a file test, and I'll just do 1, 2, 3, 4, 5, whatever. Okay. Nice simple little file. I should be able to cat test, type that to word or to what? Head 1.
Yeah.
That gives me the first line. And then how do I do last? Can't type the tail, but give me the last line of that thing. Okay, so straightforward enough so far. And type in some standard input at the head or at the tail. I want a script that gives me both the first and the last lines. So I'm gonna start making that script. Now, first, last. My first line of my script should be what?
That's good.
Shebang, then bash. Yeah. Tell the computer this is bash code that you're about to see. Okay, so I know that head one and tail one, what I wanna export. Out. Well, if I just do head and one in my script, I'll save this. My script has one actual line in it, okay? So I can almost run this first last. What do I need to do? Not executable.
Stage mount password.
Okay, so now it's green with a little asterisk, so it's a program that can be executed. Say first last. And it just waits. What's it waiting for? Some standard input. Okay. So how do I give it some standard input? I'm gonna find test file. I can pack that test and redirect it as standard input to dot slash first last. Yay, gave me the first line. We're halfway there. How do we get the second part? Oh, I could do tail or I could do tax. So let's just do the tail and one. Save that. Try this command again.
I guess like the order, it's like it gets the first line and then the tail and just like with that for something worth it, like can it not go back to the original like test?
Yeah, what's
Yeah.
happening with the stream?
Yeah.
It's not intuitive, but it's important that you kind of think about, learn what's happening with the streams. Why is it not giving us that last line? So if I just look at the my commands here. Okay. It had an input stream and it ran that. And then it sent it where? To the screen. Yeah. And then what input does this get?
Nothing.
Nothing. Got nothing. We already used up the stream.
So there's no way to do that.
Not no way.
Dollars.
$1 is the first argument to any script. So I'm gonna change this and I'm gonna say $1 here. $1. So what this reads is, give me the first line of the first argument to this script. And then give me the last line of the first argument to this script. What's an argument to a script? Let's say this. What's an argument mean in this case? Not your standard in. You would think that, but it's actually not. Which is, I think, very unfortunate. If I say ls dash dash help, you'll see a bunch of arguments. Usage, ls, here's the arguments. Whatever options you have, like the dash a or whatever, and then some files. So list a file or directory, okay. So I can say first, last, test, and that file name becomes the first argument to my script. And that's what $1 is pulling. The $1 refers to basically the first word that you put after the script that you're calling. That worked. But it didn't use our standard input stream. We had the user of this script has to give it a file name. You get the first and the last lines of it. You can't pipe a file to that. Cat, test, pipe it to first, last. I still just get the first line. You know, for being a fully fledged programming language, this is not excellent behavior. That stream that's coming in can be used once, unless we split it. So we have to make a copy of that stream, and this gets actually really confusing. So here, chat, what can I do? Bash script to give first and last lines of standard in, not requiring the file name. Oh, very easy. AWK, awk. All right, so we could do that. I'm here to tell you that awk is its own separate programming language. And look how readable it is. It's terrible. If you're an old person like me, you would know that that means new record, start with 1. We're going to take the first of the first column, which is our standard input. We'll take the last here of the standard input, and then we're going to print the first, the last. I hate that. Sed is another separate programming language. The streaming editor. Sed and 1p and $p, dollar meaning the last. That means print. So it's gonna print line 1 and then print the last line. And neither of those is actually bash. Those are separate programs that can handle this. But we could do that. So we just, thank you, ChatGPT, we'll copy that code. We'll nano our first, last. Remove these lines and just pop that in. Okay. Now I should be able to cat test and redirect the standard output to first, last. Oh, good, it works. Thank you, Sed. That's a bit trickier, and we have to like suddenly move into Sed world, which you haven't even learned about yet. And this is often why a lot of bioinformatics software doesn't just take standard input streams. It wants file names, especially if you're working with multiple files. You have a forward read and reverse read very commonly. Genomic data. Where you've got an input file name and it wants to know what should I call the output. So you got to give it multiple arguments. And so people write scripts the other way really often, where it's instead of that, they use like $1 $1. They expect arguments. Use the user. An argument is some modifier that you give to a script. So like when we say ls-l, the -l is an argument. If we say word count this file name, that file name is an argument to the word count. Right? And so here we're just capturing the first argument, $1. This is really useful, and it lets us kind of like refer to user input over and over and over again. Kind of nice, but it does a bit break the spirit of batch, which is we want to build a pipeline where the standard input becomes, or the standard out becomes the standard in, becomes the standard out, becomes the standard in. We're piping that information through a bunch of different stuff. That's all right.
So I tried doing this and I did like cat and then the command substitution, and I did head dash n1, the $n1, and then the bottom one I did the command substitution tap $1 and then type to head dash n1.
Yeah.
And then that didn't work when I did like the cat words like typing.
Yeah, you can.
Okay, but this works though. So what's like the difference? Because I use
Okay, so use $1.
yeah.
And so the first part was the same, right? Head $1, $1.
Yeah.
And then the second part, use command substitution. Describe it again.
I did hack $1 type head n-1.
Like that?
Yeah.
All right. First class. Test. That works.
Oh yeah, but if you do like cat test. And then
Oh,
type
yeah,
it-
so there's the difference. Cat test typed to first class.
So
That's the string. You get to use the string once. The string is different from an argument. So when we catted test and then typed it to first class, we didn't give first class any arguments. It came with a standard input stream and it used it up in that first line. Right, so it used it right here. That stream is now gone. Because where did it go? To the screen.
and so it just like quits after that first.
That process is over. Okay, all right, so that's the thing, is when you use the $1, you don't get to pipe things through that program anymore, in the same way that you thought. Because piping means that you've got a standard stream that becomes a standard input. The first time it gets used and sent to the screen or sent to a file or whatever, it's gone now.
So if you use any kind of like dollar sign, you can't
You have to give it an argument. So when we did it your way here, we pipe our standard output to this, but first last is actually expecting an argument and it didn't get one.
So why would the cat test like that, like output not count as anything in this case?
Because it reads it as head n1 and then $1 is nothing. Because there is no argument. Yeah, and so it used this part of the command. And then it was like, well, that's nothing, so I'm using my standard input. And then now the standard input gets sent to the screen right here. And head n1, or then the tac $1, it's got nothing to work with, because I'm just gonna argue. So the only way to do this using the input stream would be to use basically non-batch stuff, so awk or sed. And GPT can get you there. But if you don't understand why that's working or how strings work, you're gonna get in trouble down the line, because the behavior is not what you would expect. Okay, at least for me, it's kind of like, oh, right. You have to think about that stream is actually getting used up right there. We didn't give it an argument. So then there's nothing left for hack to look at. Well, I like the little streaming version that we made, the sed. So I'm gonna go back. Oops. And first last. Uncomment that. There it is. Save it. So I've got first last. Okay, I want you to put this file in your home/programs directory that you should have made last time. If you didn't, go ahead and make it. So we're outside of biocomputing now, right? So my home is one level up. Leaving biocomputing, looking around, and I've got in my home a folder called programs. Okay. So from here, in one command, how can I move that program I did for first last into this location? I'll do a move. I could do copy CP, but I'll do a move. Okay. And then oh, so you're trying to. You may have put this in your path already, maybe not, but we're gonna do that next. I want to get this program here first. I would refer to where that program is from here. I don't want to do root. I know you want me to do root. I'm not going to, because a root is an absolute path. So what's the location? Relatively from where I am currently. It's in home programs. Where did I make that file? It was in biocomputing in lesson 4. So I want to move. Move that to here. Failure. You see a directory called biocomputing in here? Yeah. So it's not in here. Biocomputing is not in this directory. This is just my programs. Biocomputing lives in my parent directory. So I have to say ... bio, and then tab complete. Oh yeah, lessons. This is where tab complete saved you. So use it as like a sanity check. So if I were just to type bio and hit tab, I get the annoying thing, meaning I got nothing. But if I do ... bio, oh yeah, lessons, lesson, and I'm gonna hit tab a couple times to see my options. lesson 4. And then I'll hit tab a couple times while I forget the name of that file. Oh, there it is, first, last, tab, and I move it here.
You have a problem with it, so it's not working.
Yes.
Okay.
If you're using tab complete, that's your sanity check.
Yeah.
By not working, is it saying file not found?
Like,
Such
when I'm
a-
trying to tab over, it's go out, it's just not like.
Yeah, so if you're tabbing and it's not working, that
Yeah.
means you spelled something wrong or you're in the wrong path. So back up and start again.
You can only use the dots out here, cause like, the programs and the biocomputing are, they're within the same like level. So you have, if you did was another thing, or if we were in a folder in programs, you have to do 2 dots, or you use 4
Yeah,
dots.
I have to do 2 dots to get back to where biocomputing is.
And do you have to separate that with slashes, or can you?
Yeah,
do
slash
both?
it.
Okay.
Yeah. Just do the like it's a different mode, it's move from there. I could. Yeah. So I could say. Home. Biocomputing. Lessons, lesson 4, first, last, move to here. That's also a nice little relative path, starting at home, it's a nice common one. But. Since y'all didn't figure this part out in any time like the 2 seconds that I thought it would take you. That indicates what to me as an instructor. Not that you're bad people. But you're still not thinking in terms of like where files live relative to each other. And that's okay, you're not born thinking that way, it's fine. But you need to start thinking about where am I at all times? Where are the files related to me? The tab is the like. It's a good friend. You can always hit tab twice. Like if I say move, and I'm like, what do I want to move? This tells me everything you can see where I am. I look and I see, oh, biocomputing is not there, but that's where I put my script. Okay, maybe it's in the parent directory. Oops. Slash. Tab. Ah, yep, there's biocomputing. Bio, tab. Where is it in biocomputing? Tab. Oh yeah, within lessons. That's tab. And then I'll hit tab and oh, it looks like everything in here starts with at least a lesson underscore. It pre-filled that for me with tab. Hit tab again. Did I put a leading 0? No. Okay. Lesson 4, tab. There it is. First, last. Move it to here. So the tab autocomplete and hitting tab a couple times to kind of see what is present in the paths that you're currently typing is a nice like, check against reality. It means you're not misspelling anything, and if it doesn't autocomplete, if there's nothing, then you've done something wrong. All right, so I'm gonna move it here. Look around, there's first, last. It's executable. Nice green, and I see this X right here. But only I have permission to execute this thing. How can I give everybody permission? If nobody else can read, write, or execute this thing. Chmod. What?
Good for everyone is an A. Like, he's like CH mod A.
Plus X just gives me permissions. Here we go. 777 gives everybody read, write, and execute, which is a bit dangerous. That means any of you could go into my folder here and delete it. 755 would give me read, write, execute. The group read and execute. And then everyone else read and execute. I love that. Okay, so, oops. So 755. Chmod 755. First, last. Then when I look at it, there we go.
If something's like in your like directory and like say like I accidentally like turn off like permissions to myself, like I can't read, write, or execute, like I might just like
I don't know. I've never taken away permissions from myself before.
I ran
I
this
would
earlier. I feel
like, did it happen?
well like I was it, like the last assignment or like assignment 2 we had to make something executive.
Yeah.
I accidentally like I turned it off from the side of restart.
So did you do like chmod 000?
Yeah, I think I don't know what I did, but
Huh. Okay. I had not thought of trying that. I don't know what's gonna happen. I can't wait. I'm gonna make first a backup. I'm gonna copy first last to first last. Backup. Okay. So I got myself a nice little backup. Notice that its permissions have been reset. So chmod 000 first last. Okay, I've removed permissions. So can I delete this? Yeah. Oh, it let me. Okay,
you just can't like edit it.
since I'm the owner, yeah. I don't know, let's try. Copy first last backup to first last. Let's restore this file. Chmod 000 first last. First last. Ooh, yeah. Permission denied. I can't edit the file.
And then if it's in this, can you turn it back to like chmod like 755 here?
Yeah, okay. So it's undoable. Kind of disappointing.
Yeah.
I mean, it's good. It's good. All right, I'm gonna remove my backup. Well, that was fun. Kind of sad that that was a fun thing, but learning new things. It's good that we can restore our permissions if we decide to remove them. I guess it's because you're the file owner. I can see this coming in handy if you're afraid that you're gonna like mess with the file, like accidentally overwrite it or something. That could prevent you from doing that. It's like, remember it gave me that little like, are you sure? Sure you want to remove this? So it's like now asking me.
So if I do like, just like a random question, like I had this other problem where I was like practicing like just like moving stuff, and then like I moved like a README file from like a lessons just in my home directory,
And then
and
overwrite.
then it overrode it.
Yeah.
So would that stop it from overriding?
It would at least give you the little, are you sure you want to remove it? But yeah. Permission denied. So maybe that's nice. Okay. Another thing some people do, I really don't recommend this because you want remove to be part of your script sometimes, but some people remove.i is interactive remove, and it will always ask you every time. So for every file or folder you want to remove, you have to say yes or no. Say no to that. So some people make an alias, and the alias is RM equals RM dash I, and so if you say remove, it's just gonna ask you every time. Not recommended because your scripts may want to remove files and you don't want somebody to have to be there at keyboard waiting and saying yes. So we've got first class, it's executable privileges across the board, living in our home programs directory. Okay. For me to be able to use this anywhere else, what do I have to do?
With the, what's like a append with this path, the programs.
You need application. So go into programs and do PWD, you need this absolute file path to your programs. And we need to add that to your path environmental variable. Okay, and that command is export path equals the current path, the value of it, and then a colon, and then the directions to programs. But that only happens the one time, and every time you log into the HPC, you'd have to redo that. So where do we put this command? Go to nano home dot batch rc. Scrolling down, there we go. So this line adds that location. So now I should, anywhere in the HPC, I should be able to say first last. And give me the first and last lines. So I made a new program real similar to head or tail. Everyone got that in there? All right, so I went up one. I'm no longer in my home. I'm in Cyclone home. If I look around, look, there's everybody. All the home directories of all the users on the HPC. All right, there's me. What's somebody else's username? I'm gonna go mess with your stuff.
Mine's right there, DR Ulrich.
Aha, okay, perfect. Dr. Ulrich. Oh. Too bad. Well, here I am looking around and I'm gonna LS1. Here's all the stuff that I'm looking at. I don't have permissions to go screw with anything, sadly. And I'm gonna LS1 and pipe that to first last. And look, tab complete worked. When you hit tab complete, it's also looking at your path or something like that. There's the first user and the last user. This worked because first last is in a location that is now in our path. Did it not work for anybody? Did it not work for you? What did it say? CD ... from your home.
Oh, I think I remember as stuff.
Oh, yeah. So you're gonna have to go to your home programs and edit. Here's last. No, that was right.
Okay.
Oh. Yeah, $1 fee, yep. Get out of there. it's better. Okay. Come on, listen command. All right, if I want to see where my first last is, the command is which, watch. Which. Where fast. And it says, oh, here it is. So that's an easy way of like editing a program or something without having to know where it is ahead of time. So I can just copy that, nano. Okay, that. You got shebang bin dash. Oh, that's it, okay. Beautiful. All right, anyone else having troubles? Okay, what's your problem?
It's like not even showing.
So. First last is not present in your path. Meaning that your programs, either it's not in your programs directory or your programs aren't in your path. Do nano underscore or let's do that again. And we'll scroll down and make sure that your export. I got a bunch of stuff. Bunch of aliens. Right, so in your .batch.rp, you're gonna have that export path equals $path. Yeah, let me just cat mine so you can see it. And then cat home dash RC. We're adding that location to our path. And only then will we be able to call the program first class. Yeah.
For file extensions for any kind of script, does that like just not matter at all as long as it's
File extensions are just a made up thing from Microsoft. They did that because originally, like file extensions don't matter, and people just kind of use them to indicate what kind of script this was going to be. So a .py means to a user, this is probably a Python script. Doesn't have to be. Now Windows comes along and they've got a bunch of different programs. Each program opens a different type of file. So they started enforcing those file extensions, saying if it has a .exe, it's an executable file. If it has a .py Python, so this is the program that's going to open it. But in reality, they don't matter. And you can go into Windows and turn them off. You know what you're doing. And that's also when you like right click and say open with other program, you get a list of things that are capable of opening that type of file. But in the actual guts of your computer, file extensions don't matter. They're nice. They're for other people. But you notice that WC, it doesn't have a file extension. It is a program. And which WC shows me it's a file that lives right there in my computer. When I say WC, it word counts things. Should it be WC.cpp? If it's written in C++? Maybe, but we don't want to have to type that every time either. I think it's actually written in C. It's really cool. Okay. Everyone good on what we've just done. We made our new program and you put it into a location that kind of makes sense. And then we made sure that that location is part of our path. So anything that I see in here, sinteract, .show, do stuff, .show we made last time. Data sets, no file extension, FASTP, I should be able to call those from anywhere on the computer. If you don't put something in your path, you have to tell your computer where it is. This is really important when working in a remote computing environment. You don't own this computer, and so the standard install stuff doesn't usually work. You go online and you see the instructions, and it's like, this to install it. This is going to tell you no. Those instructions usually are installing it somewhere like root, user, bin. You don't have permissions for that. This is a state-owned computer. So what do we do instead? We install programs like in a spot like here, programs, and then we make sure that they're findable by adding this location to the path. Okay, so first last is working. It's working without me having to say root, cyclone, home, JSON programs, first last, which I would have to do if this wasn't in my path. So that's working now. And I want to run this program on every single one of these files that starts with .bashrc. I want the first and last lines for all of them. I'm going to do that. Dun, dun, dun. Before the oh, it sounds like some of you have encountered these before. All right, what's a for loop?
For every instance, like in a, it executes like something you want it to be like in the before this, it's like the for I in like usually it's like
We should just put that on a poster as fast as possible. For every instance in a thing, it does something. It's good.
like I know how to find some of the names and stuff.
Yeah. Okay, so we can use like, let's use the jargon to start with. It iterates through every element of some set, performs the same set of actions on that element. Okay, what's that mean? We're kind of close. You've got the like computer science answer. Can we find a middle ground?
Here's that something what it really like does.
Yeah, like what's the purpose of it? What's it?
They'll do the same action on every single object instead of objects.
Okay, so what it'll do the same action on or actions on every set of objects or variables or something, list of words. Right, what can those objects be? Anything. It could be a list of words, it could be values, it could be a list of files, list of directories. So the way it works is we're going to give it some set of values. And this is really how it thinks of it. Even if you're giving it files, it's just looking at the name, like quoted of that file name. And so we're going to say, for each of the things in this list, I want you to do this stuff one at a time for each of them. And the way it works is by assigning a variable iteratively. We can call that anything. In this example, I'm saying for file in star.txt. Okay, what's my variable name? File. You can call this anything. For I, you in start.txt is really common. I is used because it's short to type and it means for iteration in. But sometimes you want your variable to mean something a bit more, like, hey, I'm going to be working the file. So for each file in, and then star.txt is the list of values that variable is going to be assigned. What is star.txt?
Every TXT file in the directory.
In that directory, it's going to look for stuff that starts with whatever and ends with .txt. So in this case, it's saying for every txt file that you see here, do echo working on $file. So I can call the variable in my loop. So I'm going to do some stuff. In this case, I'm going to say working on this file. And $file is the current value of the variable file. The first time through this loop, the current value is going to be equal to what? You don't know because you don't know all the text files, but it'll be the first .txt file that it saw. So alphabetically or however it got fed to it. And then it's going to sleep for 3, which just makes it shut down, close its eyes for 3 seconds. And then it's going to do word count number of lines of the file. Again, we're calling the current value of that, and then done. So this is the way we write a for loop in Bash for some variable name in some set of potential values. Do some stuff.
Why would you want it to sleep in
Just for fun. Otherwise, it spits it all out so fast, it's kind of hard to see what's going on. Okay, so I'll use the variable I this time. For I in .bash star. And then I can hit enter. And notice that it's just waiting for me to finish this. It's waiting for do and done. Do echo $I. So give me that actual file name. I'll hit enter. Head and one of that actual file name. Sleep for 1 second. And then done. Isn't that fun? I like making it sleep between stuff. Sleep comes in handy if one of your commands in any for loop has to like talk to another computer, like downloading a file or whatever. Sometimes there's a bit of a lag, so you can add in a sleep 3 that prevents hangups. That's what it's actually for, but I like kind of putting it to sleep. Okay. If I hit the up key, it's going to show me all that on a single line. So this is how you'll often be writing stuff. It's a single line. For I, the variable, and .bash star, any files or anything that you see here starts with .bash, ends with anything else. Semicolon, new command. Do, echo the value, semicolon. Give me the first line of the value there, semicolon, sleep for 1 second, semicolon, done.
And if you have some like and it's like using like what I'm using.
Control C will stop that loop. So I'm gonna run this again. I'm like, oh boy, I should have made it sleep. Control C. Yeah.
Why do you have one do echo, but you don't have like do head or do sleep?
Because you only do just indicates I'm starting the commands. And done means, so it's like start the loop here.
So it's kind of like almost like you're doing that and then.
It's like the indent, yeah, so although indents don't mean anything in Bash.
Yeah,
It's just setting it apart and saying like, okay, everything between do and done is what the loop, like the loop actions are gonna be.
so I, like, so just basically any first command, you're gonna have to do like do.
You have to do, so you gotta do. So there it is on one line, and the first do, or the only do that you have there, it doesn't get a semicolon. It's just basically saying, all right, here's the things I want you to do. That command, and then that command, and then that command, and then if you finish all those, then you're done. And I want you to go back and reset the value of I to the next thing that you saw. So I'm gonna try this all on one line here for your age, one word, and what did I do wrong?
I think it's something like, they took with the I in bracket.
What is going on?
All the different variable we need to find.
Yeah, I called I here. I is still left over from the last thing that it saw. So I is equal to bash RC forever. So I reset it. So the variable that I described here needs to be called the same way. Okay. Yes.
Maybe done with it, but how are they reaching number values of the is it just?
The curly bracket 1.10
Oh, okay.
is, I'm just giving it a set of 1 through 10 now, right? So any set that you can give here, the value of the variable your age, first time through will be the first item in that set. Then it's done, it goes back. Second time through, it'll be the second value, and that's the second element in that set. So on.
So does that work differently than like the solar after that, or is it kind of something?
It's just however you want to indicate, here's a list of things that I want you to be equal to.
Doesn't have to be a certain way. Okay.
Yeah, it'll accept any list of stuff. So if you've got file names. So if I do this. Dot bash star. Now I'm giving it a list of all the files that start with dot bash, end of anything. Dot bash RC. How are we feeling about these?
So with the like your age group, I'm like that's not gonna reset until you close it, like exit.
Yeah, so now if I echo I can even tab echo your age, and it should be this one. That was the last one that it was equal to.
Gotcha.
So now you've got this like leftover variable just kind of hanging out there, but you could remove it, override it. It's not gonna hurt anything, probably. Okay, so we've got our first last program. It's in our path. Let's call it on every single one of these .bashrc files. Go for it. I want the first and last line of every .bash whatever file that you've got. Using a for loop and your brand new fancy program in your path.
For every. Oh, God,
For every .bash star.
okay.
Yeah. Sure can. Bash star to add vocabulary. Yeah. First class doesn't take a file name, it's standard input. So I'm gonna cat that file. Type the standard out in the first last. Yeah. Yeah, cat wants a file. And so since we were giving it files the first last on, if we echo v, it's going to give us the actual value of v, which would be the file name. If we cat $v, it's going to take that file name and spit out the contents. I could add both. I could say do echo $v and then if I could have it give me the current value of that variable v and then cat contents of any file that happens to be named that typed in first class. And oops. And so there you've got the file name, first and the last. File name, first, last, first, last. Okay, what good does this do you? The script we just wrote is not groundbreaking stuff. Not solve some major problem in bioinformatics. But if you've done this, it's really good. Me as a teacher, I'm like, oh yes, you've done the thing. You've written a script, added it to your path, used the for loop to call it on a bunch of files. Yeah, we're getting like a little smiles here and there. This is good. Well, all that's left is what? To learn how to use other people's scripts, add them to your path, call them on a bunch of files, write your own little script that pulls together a few of their scripts, add that to your path, call it on a bunch of files. And so the rest of the semester, that's what we're focusing on. Well, the next 4 weeks, essentially, is getting us to that point where we're downloading and installing new programs that other people have written, making sure they live somewhere where we should call them, and then downloading a bunch of files to work on, calling that on those files. That's the pipeline. Of course, we don't get to do that here on the login node for very long, because once we start getting big files, we'll get in trouble. We start using more time or more resources on the login node. We'll have to learn how to talk to Slurm, the resource manager, and say, I want this job to be run on that cluster. This much time limit and this many resources. And it's going to have to be able to find the files that you're interested in and find the scripts that you've written. That takes thinking about where the files live. So we'll add in those paths to our script and all that kind of stuff. And then that's it. You're suddenly writing pipelines. I think our foundation's ready for that. And lesson 4. Yeah, okay, it's ready. Focus on that. And then assignment, what are we on 4 now?
Yeah.
Not group project. Assignment 4. Go ahead and start this. You have done this part before. For assignment 0, before class started, you installed GH, which handles your GitHub like credentials and everything on the command line. Cool. Well, this assignment is to install that on the HPC.
I mean, you can push.
So you can push directly from the HPC. Yeah. I couldn't have you do this before you learned about how like the paths work and everything, but it's going to have you make programs that you've already got. You're going to download and unpack this tar ball. It comes in a .tar.gz format. So you're going to use the program tar to unpack it. It's just like a zip where we used unzip before. GPT will get you through there, but it looks like tar xz via the file name. But you're going to unpack it into your programs directory and then make sure the path to the executable GH is in your environment variable path. And then suddenly you can call it. This installation script or the installation instructions, I want you to turn into a script. So I'm gonna go to my CD programs. I've got installation scripts. Right, and so it's just all the instructions for getting this thing installed. That's it. Unpacks it, moves it. Right. So you're ready for this assignment. It'll be due along with the next quiz in a week, Thursday. And then at the end, you're also going to install this CTK program, our first actual bioinformatics tool that somebody else has written. Almost all the bioinformatics tools we have access to in here, we're going to have to install ourselves. We could have the admin do it, but that's not really portable. We need to know how to install stuff. So that's how we at the end. Have a wonderful weekend of installing these. Thursday. Yeah. So quiz and this assignment due Thursday. I'll have lesson 5 up by this weekend on the drive. A place to work through.
Was it still like a week behind or?
Yeah, there's still a week behind. If you have a problem with that,
No,
then we
no,
can.
no, no.
We can do 2 quizzes next week. All right.